Good morning, students. Welcome once again to the next section of our class. Today I'm going to deal with the topic 3 Wattmeter method. 3 Wattmeter method. You can also find the total power in a three-phase system by connecting a wattmeter in each phase of the system that will measure power in each phase. Then after you had the power, the meter reading, the wattmeter reading, you add it together, that will give you the total power in the system. When you measure the power delivered by connecting the wattmeter to the system, you connect each wattmeter current coil, you connect it in series with the line, and the voltage coil, if depending on what connection, if it is three-phase, 4 wires, star connected system, you connect the voltage coil, the voltage leg to the neutral wire. But if it is three-phase, 3 wires, star connected system or a delta connected system, you connect the voltage leg to each other. You connect it so that it can form something that looks like a star connection. So let's look at an example of what I'm talking about. Let us assume we have a star connected system that is three-phase, 3 wires. In this sense, let us assume this goes to the load, the three-phase system that is either star or delta connected. What you do is the voltage coil, the voltage leg of the coil, you connect it to each other. When you connect it to each other, it forms something like a star. It forms something like that. So this is wattmeter A, wattmeter B, and wattmeter C with their series current coil on their line. Then the voltage coil connected to each other. So when the voltage coil is connected to each other, it forms something like a star connection. Then the voltage coil form a balanced star connection, right? Then the voltage across each coil will now be the line voltage divided by √3, because it has formed a star connected system. So if the voltage across each voltage will lag the line voltage by 30 degrees in a positive phase sequence. If it is positive phase sequence, the phase voltage will lag voltage across the coil, which will appear like the phase voltage. Let me call it a voltage across the coil. Will lags the line voltage by 30 degrees. If it is negative, it leads by 30 degrees. It leads the line voltage by 30 degrees. Right. So now the power measured now will be determined like this. Let's say you want to determine the power in any of the wattmeter. The power will now be the V line by I line cos V line I line plus or minus 30 degrees. That will be wattmeter reading. So this plus or minus 30 degrees will be determined by what type of rotation it is. So this eventually, this line voltage, the line voltage as we have it here is now going to look like a phase, because this is the line voltage, which is now, because of the star connected form, is forming a star point, which means it has to be divided by root 3. So this V line will now be divided by root 3 I line cos V line I line plus or minus 30 degrees. You understand? So now, if it is positive phase sequence, if it is positive phase sequence, if it's positive phase sequence, you will, whatever the angle between the line voltage and negative and the line current is, you will subtract 30 degrees from it. If it is positive phase sequence, right? If it is negative phase sequence, you will add 30 degrees to it. So what will determine which one you will use between the positive and the negative will be the direction of rotation. If it is positive phase sequence, you will subtract 30 degrees from the angle difference between line voltage and line current. If it is negative phase sequence, you add 30 degrees to it. Thank you.